Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are focusing on normal distribution, and in the continuation of the classes that we had on campus, this is lecture number 5. And yes, it's a topical review because we would be solving past paper questions over here, and we'll be solving some of the difficult past paper questions that were given to you for homework and some other ones. Now, for example, this question was not given in homework deliberately. We are solving it right now. So let me first read the question. Let me grab a highlighter and let's get started. Melons are sold in 3 sizes: small, medium, and large. The weights follow a normal distribution with mean 450 grams and standard deviation 120 grams. And then it further says that melons weighing less than 350 grams are classified as small. First part, find the proportion of melons which are classified as small. So let's focus on this one. First of all, you should write the distribution. That is, X follows a normal distribution 450, 120 square. And then we need to find the probability. Probability X is lesser than 350. So I hope everyone is equipped with a calculator. So make sure that you do the calculation also side by side. So now this is, let's standardize. This is about the 7 rules. Z is lesser than 350 minus 450 divided by 120. And this is 100 at the top, 120 at the bottom. Z is lesser than negative 5 over 6 after simplification. Now, which rule is this? This is lesser than a negative value that is greater than a positive value. This is rule number 4. And this is about flip, inequality, and remove negative sign. That is what the rule is all about. So therefore, first of all, I'll write Z is greater than a positive value. And then this becomes rule number 2. And this is indirect reading. What do I mean by indirect reading? Read the probability and subtract from 1. So 1 minus probability Z is lesser than 5 over 6. 1 minus. Now let's go to the table. But before that, let's convert 5 over 6. Now 5 over 6. After simplification, this is 0.833. 1, 2, 3 decimal places. That's more than enough. For Z value, 3 decimal places are more than enough. So let's go over here. This is 0.8 and then 3. So that is this one. Let's focus on this. And then a 3 over here. So let's keep on going. And this is the value. So 79, 67 plus 8. So let me write over here 79, 67 plus 8. That comes out to be 7975. That is the value that we get. So this is 1 minus 0.7975. When we do the subtraction, this comes out to be 0.2025. For this particular part, you have to round it off. So write the 4SF value also. And then 0.203, write the 3SF value. And that is the final answer for this particular part. So that is question number 1, part 1. It's done. So now, since I want things to go in a flow, so I won't waste time in going back to the WhatsApp and then asking you to acknowledge it, because that would be wasting a lot of time. I hope this is all good, all clear. So now this thing is done. Now let's move to the second part. It says the rest of the melons are divided into, hold for a second, let me make it small. The rest of the melons are divided in equal proportions between medium and large. Find the weight above which the melons are classified as large. Now, what needs to be done over here? So now the thing is, let me draw a number line, and there is this weight that is 350 grams, and lesser than this is classified as small. There should be a particular weight, let's call it M, above which it will be classified as large. And in between the two should be medium. That means the probability of this plus this should add up to 1. Now, the probability of small, the unrounded value is 0.2025. So 0.2025 plus a probability P for this one plus a probability P for this one should equal to 1. Now grab your calculator and evaluate the value of P. So 1 minus 0.2025 divided by 2, that comes out to be 39875. Therefore, P is 0.3987 and 5. And now let me draw the number line over here. So I need to add a page. And let me draw the number line over here. So this thing lesser than 350, this is 0.2025. Greater than a particular value M, that is 0.39875. And this thing over here, that is also 0.39875. Now for this thing, yes, I need to go to the WhatsApp. So just hold for a second. Let me grab my phone. And one other thing, let me just open this thing over here. Okay, so now is this number line in the millions question, is this all clear? Just acknowledge this. How have I solved this? So yes, you need WhatsApp over here. And this is grade 2, grade 1. Hold for a second. Okay. So now let me explain it once again. First of all, lesser than 350, it's 0.2025. Let me just call it roughly 20%. That means these two should be 80%. Divided equally should be 40% each. Exact value is this. Therefore, I simply wrote it over here. That means now, based on this number line, I have to form the equation. That is, the rest of the millions are divided in equal proportions between medium and large. Find the weight above which millions are classified as large. So now we need large millions. We need that particular value. So therefore, I would say part 2, probability, and let me make the marker thicker, probability x greater than m is 0.39875. Now, let me go over here. I hope it's clear, whoever asked this question. And very few people are acknowledging it. Be a little bit speedy. And is this inequality all good, all clear? Greater than m is this value. Lesser than m, we have to do it. Why should we be doing it? Because we know that the minimum probability has to be greater than 50%. So therefore, let me flip the inequality and I'll write probability x lesser than m is this plus this. So again, let me grab the calculator. Plus 0.2025, and this comes out to be 0.60125. That is the value that we are getting. So now what needs to be done? For probability purposes, let me write this thing as 0.6013 because the probabilities are given correct to 4 decimal places. So now 6013, let me go over here. Can I locate 6013? So let me grab a blue marker. 6013, 6013, 6026, 5987. That is corresponding to 0.2, 5, and 6013. and this is 5987. So 13, 13, I need to add 26. Let me keep on going, keep on going, keep on going. And I don't have 26, I have 27. Let me choose 27, and that is under the 7. So therefore 0.257, that is the Z value. So now the Z value corresponding to this thing is 0.257. Now let me do the working once again. Probability Z lesser than M minus 450 divided by 120 is 0.6013. Probability Z lesser than some value is 0.6013. This particular value is how much? That is positive because of the lesser sign, minimum probability greater than 50%. This is 0.257. Now let's solve it out. Therefore, M minus 450 over 120 is 0.257. Therefore, M is 0.257 into 120 plus 450. And let me also double check the working. 0.257 0.025 481. So the rounded off value is 481 grams. That is given correct to three significant figures. That means if I draw a number line, the rule is lesser than 350 grams is classified as small, and greater than 481 grams, that is classified as large. And in between the two, this is classified as medium. So that was the classic question, and you would see many more questions like this. So that is the classic Mellon's question, and I hope this is all got all clear. So this is AS script 1, this is AS script 2. Okay. So now this is all got all clear. Of course, you can copy it later when this will be uploaded on whichever platform that is. So now part 1, part 2, it's all done. So now I have deliberately put this table over here so that you can see the working in complete detail. The first part was about the 7 rules. The second part was about back solving. Now let's move to the next question. Now the next question, this is question number 16. It says the random variable X is normally distributed, and there are 2 parts to this. So let me just add a page, and I'd be needing more space. So let me add it over here and like this. And this is part A. Okay, now the part A is done over here. It says the random variable X is normally distributed. The mean is twice the standard deviation. So first of all, let me just reduce the brightness. Okay. The mean is twice standard deviation. That is the rule that they have given. And it's all symbolic. So I'll write X follows a normal distribution mu comma sigma square. So instead of mu, write 2 sigma. So X follows a normal distribution. This is 2 sigma comma sigma square. Got the idea? That is easier this way. So this thing is changed. The mu is changed to 2 mu. The mu is changed to 2 mu, 2 sigma. It is given that probability X greater than 5.2 is 0.9. Probability X greater than 5.2. Probability X greater than 5.2 is 0.9. Let's standardize. Probability Z is greater than 5.2 minus mu divided by sigma is 0.9. Probability Z is greater than 5.2 minus 2 sigma divided by sigma is 0.9. And then probability Z is greater than some value that is 0.9. This is 90%. Greater sign, Z value will be negative. Very famous value. That value is given from the strip. The 90% is corresponding to 1.282. So let me write over here that is 1.282 with a negative sign. You know the reason for the negative. So the first part is about back solving. So 5.2 minus 2 sigma divided by sigma is negative 1.282. 5.2 minus 2 sigma is negative 1.282 sigma. And let me take it to the other side. So therefore, negative 2 sigma plus 1.282 sigma is equals to 5.2. Make sigma the subject and you will get the answer. Let me get the answer from here. That is right over here, either 7.24 or 7.23. So let me write 7.23 over here, correct to three significant figures. Of course, you can do the working yourself. So that was pretty basic, except it felt like a simultaneous question. Technically, it is because the relation between mu and sigma is given, and that was substituted. All good, all clear? So this one is back solving. The second type of question, we have done it in class. That was about one standard deviation from the mean, two standard deviations, and things like that. So let me just write it over here. Now it says a normal distribution. Again, it's again symbolic. So a normal distribution has a mean mu, standard deviation sigma. X follows normal distribution mu comma sigma square. If 800 observations, now this is the first time you are seeing in a past paper question, observations. This observations could be about apples, it could be about a particular plant, and so on. So whatever data that we are observing, that is the observation. If you're talking about apples, apples is the observation. If 800 apples are taken from the distribution, how many would you expect? Remember the word expect, expectation, expected value, something to do with that. Lie between mu plus sigma, mu minus sigma. So this means lying within one standard deviation of the mean, because this is over here. Let me just show it a little bit more better. So now this is about two values. And it's lying within one standard deviation of the mean, because this is between mu plus sigma, mu minus sigma. This is mu. And let me just erase this thing right now. This is mu. This is mu plus sigma. This is mu minus sigma. And we are looking for this probability. So step one is this thing. That is x follows normal distribution mu comma sigma square. Probability x lies between mu minus sigma, mu plus sigma. Probability z lying between mu plus sigma minus mu divided by sigma. Mu minus sigma minus mu divided by sigma. So therefore, this simplifies to z lying between -1 and +1. So now let me just erase this thing. Let me center it in the middle. So when we do the standardization, we subtract mu and then we divide by sigma. That is how it's done. So mu cancels out, sigma over sigma. Over here, it's -1. Over here, it's +1. And now this is rule number 7. Z lying between two values, one is positive, one is negative. So this is phi of the first value. You have to discard the negative sign. That is obvious. Phi of the second value, add it up, and then subtract 1. So now these are very common values. That is 0.8413, 0.8413 minus 1, and this comes out to be 0.6826. I remember this value. Now this is the probability, but they're asking for expected value. So basically, y follows a binomial distribution 800, 0.6826. And they are asking for expected value. That is n and p. So that is 800 into 0.6826. Grab your calculators, evaluate. So that is 800 into 0.6826. The answer is coming out to be in decimals. That is 546.08. When we talk about observations, when we talk about apples, when we talk about some other things like this, the answer has to be an integer. So either give the answer as 546, that is 100% acceptable, or give the answer as 547, that is also acceptable. It's necessary whenever they are asking for the expected value answer, this has to be given as an integer. So now this thing about expectation, this is question 16. This is about expectation, expected value, and integer. I hope this is all good, all clear. So this is group 2, this is group 1. Yes, both are accepted. Over here, that is the answer. 546, 547, they have used 2/3 as this value. I don't know. This is just ignore this. Okay. 546, 547, both are accepted. All good? Let's move on. Now, question number 22. And again, let me just copy this. I think it would fit in over here. Okay, let me just write it properly. Okay, now let's read the question first. The question says, the volume in milk in milliliters in carton is normally distributed. Mean is mu, standard deviation is 8. Measurements were taken of the volume in 900 of these cartons. That is something similar to this. We had 800 observations over here, and this is 900 over here. It was found that 225 of them contain more than 1002 ml. So now the very first thing that you need to realize is this thing. 225 out of 900, that is the probability. So the probability was given as a fraction, as a ratio, as a proportion, something like that. 225 out of 900 that contain more than 1002 ml, find the value of mu. X follows normal distribution, mu, comma, 8 square. Probability X greater than 1002 is 225 over 900. So now what is 225 over 900? Let me divide. 225 divided by 900 should be a nice number. That is 0.25. Okay. So this is 0.25. This is probability X greater than 1002. But this probability is less than 50%. So what should we do? Flip the inequality. Probability X lesser than 1002 is 0.75. Carry out the working. Probability Z is lesser than 1002 minus mu divided by sigma is 0.75. Probability Z lesser than some value is 0.75. Go to the table, go to the strip. That is the value, 75%, corresponding Z value, 0.674. Lesser sign, Z value is positive, 0.674. So therefore, 1002 minus mu divided by 8 is 0.674. 1002 minus mu is 8 times 0.674. Therefore, mu is 1002 minus 8 times 0.674. So 8 times 0.674. This is 5.392. This is 1002 minus 5.392 and 1002. This comes out to be 996.608. 996.608. Therefore, this is 997. That's the value of mu, correct to 3 significant figures. No harm in double checking. That is 997. All good? So now let me copy this question and let me take it on the next page. Now it says the second part. Let me highlight it. 3 of these 900 cartons are chosen at random. Calculate the probability exactly 2 of them contain more than 1002 ml. Now, what is this question all about? First of all, realize this fact. that this is probability question naturally. It says so. And what kind of probability? This is like the kind of basic probability, but this is without replacement because if one object is taken, the total will reduce. So what is the answer? 225 out of 900. So basically, you have three fractions to deal with. You have one fraction, you have other fraction, you have a third fraction. The denominator is 900. It will reduce to 899. It will reduce to 898. What about the numerator? The numerator, that is 225. It gets reduced to 224. It gets reduced to 223. That is the basic thing that is used over here. And what else? Exactly two of them contain more than 1002. So more than 102 is 225. So this is 225. This is 224. Let me just simplify this. This is 900 minus the value. So how many are used? 900 minus 225, the original value. That is how many these are. So 1002 greater is 225. 1002 ml out of 900. So 900 can be divided into two categories. 225 are greater and 225 minus 900, remove the negative sign. That is 675. That is lesser. Got the idea? So now this is exactly 2 are greater than that and contain more, and one contains less. Now, there is one missing piece of the puzzle. That is, there are three ways of arranging it. So this is AAB, ABA, BAA. So I think this was one tricky question that came all of a sudden. So just acknowledge if this thing milk question. So now this is the milk one. And which question is this? This is 22. 22 question, the milk question. And is it all clear? Because this is without replacement. Now, someone can have this idea that can it be done using a binomial? The answer is no. It cannot be done using binomial. The reason is because the probability is not fixed. Since this is without replacement, therefore binomial model is not applicable because the probability is not fixed. Is this thing all good, all clear? So how have they written it? 225, 224, 675, 900, 899, 898, and so on. That is how it's done. And they have also done it using combination. So let me also tell you how can this be done using combination. So if we talk about combination, alternative, let me draw a box over here. So this is alternative way. That is one category is that of 225. The other one is 675. So lesser, that is 675. Greater, that is 225. And you want to select one out of here. You want to select two out of here. And this is 675C1 into 225C2. That will give you the number of ways, and divide by 900C3. That is without any restriction. So basically, this will be written as 675C1 into 225C2, the whole thing divided by 900C3. That should be the answer. 225C2, 675C1, 900C3. That is how this thing is done. So very, very unique question. So I hope this is all good, all clear. Let's move on. The normal distribution was not that used because the numbers, yes, it was used, but to a lesser extent. And now this is also a very classy question. So this is called a box plot. And of course, we will study it later, but just to give you an idea what a box plot is about. Box plot and normal distribution. I'll explain to you just right now. AS1 and this thing. Okay. Now, there is this diagrammatic representation. This is called box and whisker diagram. Now, what is a box and whisker diagram? We just need two things out of here. In this thing, we should know that this thing is lower quartile, this thing is upper quartile, this bar over here, this corresponds to lower quartile. This bar over here, this corresponds to upper quartile. And this bar in the middle, this particular value over here, that is the median. Now remember, when I talked about normal distribution yesterday, I said normal distribution is a symmetric probability distribution. That was taught in the beginning of the class. Symmetric probability distribution, that is one thing. And the second most important thing is that the mean is halfway between lower quartile and upper quartile. And the next thing is the mean is the same thing as median, because median is associated with lower quartile, upper quartile. So in normal distribution, mean is the same thing as median. That is the first thing. So now let me write these things: the mean, the median, the lower quartile, the upper quartile. And which question is this? This is question number 26. So that is the scenario over here. So now over here, this is group 1, this is group 2. Okay. So now over here, first thing is the median. It says, even before that, let me read the question. So the question basically says this: measurements of wind speed at a certain island were taken over a period of 1 year. A box and whisker plot of the data obtained is displayed, excuse me, is displayed above, and the values of the quartiles are shown. Bigger one is upper quartile, smaller one is lower quartile. It is suggested that the wind speed can be modeled approximately by a normal distribution with mean mu and standard deviation sigma. Estimate the value of mu, 1 mark. Estimate the value of sigma, 3 marks. They have given only 1 mark for mu because it was very obvious. That is, mu is halfway between lower quartile and upper quartile. That is halfway between what are the two values? One of them is 39, the other one is 63. 39 plus 63, that is the same thing as 40 and 62. So that is 102 divided by 2. That comes out to be 51. So the value of mu is 51. That is the first thing that we get. Mean is 51. Now, the next thing, estimate the value of sigma. We know that lesser than upper quartile lies 75% of the distribution. So lesser than upper quartile is 75%. We should also know that lesser than lower quartile is 25% of the distribution, but we don't need it as such. So now lesser than lower quartile lies 25% of the distribution. This is from basic cumulative frequency of O level or IGCSE maths. So now let's use the upper quartile. So therefore, this is part 1 that is done. This is part 2. That is probability x less than 63 is equals to 0.75. Now we already know the value of mu. So x follows a normal distribution, 51 comma sigma square. So probability z is lesser than 63 minus 51 divided by sigma. That is 0.75. Probability z is lesser than some value. That is 0.75. Again, let's go to the table. So this is the 75% z value, 0.674. So this is 0.674 positive value because of the lesser sign. So therefore, 63 and 51, the difference is 8 over sigma. That is 0.674. Therefore, sigma is 8 divided by 0.674. Use a calculator, simplify, and this comes out to be 17.8, correct to 3 significant figures. Or 17.8, correct to 3 significant figures. So I hope this is all good, all clear. This was the new knowledge that you learned, that this is called the box and whisker diagram. And the two ends of the boxes, the smaller one is the lower quartile, bigger one is upper quartile. Lesser than upper quartile, that is from O-level maths, lies 75% of the distribution. Lesser than lower quartile lies 25% of the distribution. Now, someone can ask this question, can we solve it using this probability x greater than 39 is 0.75? Of course you can. Can we solve it like this? Probability x less than 39 is 0.25? Of course you can. Can we solve it like this? Probability x greater than 63 is 0.25? Yes, but then this is lesser than 50%. So automatically it would convert, it will be converted to this one. So I hope this is all got all clear. Question number 26, that's done. Now this is one classy question. And let me solve this question in class. So let me just ignore this one. Yes, I'm not solving it right now over here. I'll be solving it in class because, okay, but since I've pasted it and since this video is being recorded, so let me solve it. So now it says, let me link two things together. I would be linking part 1 and part 2 together. And then on the next page, I would be solving part 3 separately. Now, first of all, the first part was done in class. X follows normal distribution 125, comma 4.2 square. That is the distribution. Part 1, find the probability randomly chosen bar of soap weighs more than 128. Basic 7 rule question. X is greater than 128. Probability Z is greater than 128 minus 125 divided by 4.2. Probability Z is greater than 3 over 4.2. How much is that? 3 divided by 4.2, hold for a second. That is 0.71428. So probability Z is greater than 0.714 because the Z value, we have to restrict it to 3 dp. Now, which rule is this? This is rule number 2. That is indirect because it's greater than a positive value. This is 1 minus probability Z is lesser than a positive value. This is 1 minus something. Now I have to go to the main table, 0.714. This is 0.7. This is 1. This is 0.71. And then keep on going, keep on going, keep on going till you reach the fourth value. That is this. Under the fourth value, we are reading this. 7611 plus 12. 7611 plus 12. How much is that? 7623. That is the value that we get. So this is 0.7623. So 1 minus 0.7623. This is coming out to be 0.2377. 0.2377. That is the first thing that we got. I hope this basic thing is all good, all clear. So now I'm running short of space. Let me move to this page and do the next question. And let me just switch the place over here. Okay. So now over here, let's focus on the second part. That says this is the tricky part for 4 mark. It says find the value of K such that probability X between K and 128 is 0.7465. Now, the very first thing that I want to state right away, that the way that I have explained to you back solving, that is only for single value. Make sure the probability is at least 50%. If not, subtract the probability from 1 and flip the inequality. Z has a lesser sign, Z value positive. Z has a greater sign, Z value is negative. But now over here, this is about back solving and it's about a range. So what should I do? Let me grab a number line and let me label it just like that Mellon's question. So now over here, somewhere here is K, somewhere here is 128 and greater than 128, you just got it. Greater than 128, how much is that? 0.2377. So this one is 0.2377. Between K and 128, this is 0.7465. This is 0.7465. Now you tell me what to do. This is just like that Mellon's question. Just go all the way extreme right of a particular value. That particular value is K, all the way this way. That means 2377 plus 0.7465. This comes out to be 9842. 0.9842. That means the equation is probability x greater than k is 0.9842. Got the idea? Let me explain to you once again. In the first part, you calculated probability randomly chosen bar weighs more than 128. That's right over here. Greater than 128, standardize, apply the rule, get the answer. And in this one, let me just write one thing. This is 4SF answer. For this part, the final answer will be 0.238. That is 3SF. But whenever you have to use for any other part, use unrounded value. So I use this value. I drew a number line. Between K and 128 is approximately 75%. Greater than 128 is approximately 23%. Greater than 128 is 23%. Between these two, 75%. Therefore, all the way greater than K, all the way greater than K is this much. And now you are fit to solve this question. So probability Z is greater than K minus, how much is the value? 125 and 4.2. So K minus 125 divided by 4.2 is 0.9842. Probability Z is greater than some value is 0.9842. And this is a greater sign. Therefore, the Z value is negative. And 9842, where is the table? 9842, that is right over here. So 9842, 9842, exactly over here. 9842, 2.1, and this is 5, 2.15. Okay, got the idea? So now let's come back over here. This is 2.15. Comparing coefficient. Therefore, K minus 125 over 4.2 is negative 2.15, negative because of the greater sign. K minus 125 is equals to negative 2.15 into 4.2. K is equals to 125 plus 2.15 into 4.2, 2.15 into 4.2, 9.03. And this is 125. This is 115.97. So this is 9.03 negative. So this is negative 9.03. This comes out to be 115.97. Therefore, the value of K is 116, correct to three significant figures. No harm in double checking. So there it is. All good, all clear. So now that is that SOAP bar range question. Let me type it out. So this is the SOAP, and this is the SOAP bar, and this is the range number line question, a very classy question. So now two parts are done. The third part is normal, but that is also nice. AS2, AS1, all good. And this is question 27. Okay. Now let's look at this part. Now this part, it's about 5 bars of soap are chosen at random. Find the probability more than 2 of these bars each weigh more than 128 grams. What is this question all about? Whenever we are talking about more than one object, it becomes a binomial scenario. This becomes a binomial probability distribution. Whether they are talking about 800 observations or 900 cartons or 5 bars of soap, that is binomial. So you would write X follows binomial distribution, binomial B for binomial, 5 comma something. What is that something? What is the probability of success? More than 128 grams, more than 128 grams, And this answer of part one, the unrounded, I think that was 0.2377. That is the probability of success. And then it says exactly, no, more than 2. Probability x greater than 2. More than 2 is probability x is greater than or equal to 3. So therefore, we would write 5C3 and then 2 brackets and then 5C4. Let me make the brackets closer. And then 5C4 and then 5C5. The probability of success is this thing that is over here. That's the probability of success that will go over here, go over here, go over here. So therefore, let me write it down. 2377, 2377, 2377. And then the probability of failure should go over here. That is over here, 1 minus 0.2377. 1 minus 0.2377. And it's better that you draw a 0. It's better that you draw a 0. This is 1 minus 0.2377. And what about the powers? So this is 3, this is 2, this is 4, this is 1, this is 5, this is 0. Calculate, 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 add it all up. Again, 4 marks, and that's your answer. No harm in double checking. There it is. This is it. 5C3, 5C4, 5C5. Write down all the answers separately. The final answer is 0.90910. 3 significant figures. 0.0910. So write, add it up. 0.0910 and always make sure to state the level of significance. So now again, the soap question, and this time this is about the binomial and we use the probability. I hope this is all good, all clear. AS1, AS2. Okay. Now, a similar question that we have solved earlier, similar, not exactly the same, similar. Now it says the times taken by students to get up in the morning can be modeled by a normal distribution with mean 26.4 minutes and standard deviation 3.7. So I think I'll be needing 2 pages. So let me add a page over here. Okay. Let me add this thing over here. Okay. So now over here, it says the distribution X follows a normal distribution 26.4 comma 3.7 square. First part, it says for a random sample of 350, find the number, expected value, expected number. Who would be expected? Oh, the expected word was later on. To take longer than 20 minutes to get up in the morning. Probability X is greater than 20. Probability Z is greater than 20 minus 26.4 divided by 3.7. Probability Z is greater than a negative value, whatever that is. That is 1 minus probability Z is less than the particular positive value. That is 1 minus something. We will get this answer. Let me grab the answer from here. So this is negative 1.730, 9582. So 0.9582, 0.9582. And let me also get this answer. So let me show you the working without skipping any steps. So this is 6.4 divided by 3.7. That is 1.729730. 729, so 1.730. So this is 1.730, 1.730. Let's go to the table. So this is 1.73 and that's over here. This is 1.7123. This is 9582. Okay. 730. So that is good. 1.73, 9582. So this is Z greater than a negative value, therefore Z lesser than a positive value. My bad. I applied the wrong rule. So this is simply flipping. Flip in equality and remove negative sign. Now, in a hurry, I made a small mistake, and let me share my mistake with you. So my bad. Okay. That applied the rule with the negative sign. No, first you have to flip the inequality and remove negative sign. So probability Z lesser than a positive value. This is direct reading. This is rule number one, and that's how you get this answer 9582, which can be rounded off 0.958, correct to three significant figures. All good, all clear? So that is the first one. That is the morning question. The second one. Now, what does it say? It says very slow students are those very slow students are students whose time to get up is more than 1.645 standard deviation above the mean. Now, when we write it like this, 1 SD above mean, it means mu plus sigma. If I write within 1 SD of mean, it means lies between mu plus sigma and mu minus sigma. We solved question like this in class and today also. It says 1.645 standard deviation above the mean. So that means mu plus 1.645 is t. So let me first calculate the probability. So probability x is greater than mu plus 1.645. And we don't need the values at the top. We can just use the x and mu thing. X follows a normal distribution, mu comma sigma square. So now let me just use it. I can even use the values. I can just use it symbolically. Probability Z is greater than mu plus 1.645 sigma minus mu divided by sigma. Now what is happening? The mu and the mu cancels out, giving you 0. And this sigma and sigma divides, leaving behind 1.645. So probability Z is greater than 1.645. That is a positive value. That is 1 minus probability Z lesser than 1.645. This is rule number 2, indirect reading. That is why we are subtracting from 1. 1 minus 0.9500, that is 0.05. I remember this value. Let me show you where it is. 1.645 Z value is giving you 95%. 1.645 value is giving you 95%. So 1 minus 95% is 0.05 or 5%. If you write in percentage, that's 5%. If you write in decimals, that's 5 over 100, 0.05. It's not over yet. Now it says find the probability fewer than 3 students from a random sample of 8 students are very slow. Now this is binomial. So now you would write y follows a binomial distribution 8, comma 0.05. 8 is the number of trials. P is the probability of success and fewer than 3. So probability y is lesser than 3. Probability y is lesser than or equal to 2. That is 8C2. Let me write with 8C0 and 8C1 and 8C2. Now your success is this one, that is 5%. So that is 0.05, that is 0.05, that is 0.05. The powers are 0, 1, and 2. And your failure is 95%, 1 minus success, 0.95, 0.95, 0.95. The power is 8, the power is 7, the power is 6. You should get this probability. Let me write it down. You should get this probability. You should get this probability. You should write this probability separately. And then you should add it all up. Add it all up. And remember, work in 4 SF at least, so that the final answer is 3 SF. So now, what is the answer? That is this thing, 0.6634, 0.2793, 0.0515. The final answer is 0.994. The very, very final answer is 0.994, correct to 3 significant figures. That is the answer for this particular one. Okay, so I think that's enough of practice for today. Let me stop the working over here. So maybe in the next video, we can start working from this question downwards. Take care.